Hi, welcome back. In this video, we're going to talk about function behavior. Specifically, we're going to talk about when is the function increasing, decreasing, or remaining constant. Now, these words are literally, they mean what they mean, right? As you read the word increasing, what is the word that you think of? Increasing means that it's going up. Decreasing means that it's going down. And constant meaning that there's no change. There's only three possibilities for a function, right? Regardless of what you're looking at. No matter what happens, there are different locations in the graph where it's increasing, decreasing, right? There's only three possibilities, and it's one of these three. So let's describe the changes that are happening for different scenarios. Here we have a parabola, or a quadratic, and I identify first that this location is a critical location, right? It's a critical point. Now, as I define the locations where the function is increasing or decreasing, I'm literally just going to look at the graph and see where it's going up, where it's going down, or where it's not changing. And I can see here that the graph is going up, which is increasing. And then here, from this point to the right, the function is going to decrease. So how do I describe this location? Well, I want to focus on the domain. The domain is the set of all inputs. So if I can describe the inputs, right, I'm by default also describing the output. So where is the function increasing? Well, on the left side, if I look at the x-axis, I'm going to start at negative infinity on the left, and I'm going to go all the way to this point, all the way to negative 1. So from negative infinity to negative 1, the function is going up or increasing. And then from 1 to positive infinity, to the right, from left to right, the function is going down. It's decreasing. Notice how at 1, it's neither increasing or decreasing. So if the function is, if you have a location where it's doing both things, it's part of going up and it's part of going down, we're going to use the parentheses to denote the location. So this just says everything between negative infinity and negative 1 is increasing. And everything between those two. And everything between negative 1 and infinity, it's going to be increasing. And here we have no situations where the graph is constant. Constant meaning that there's no change. It's just flat. Now, domain and range, there's a previous video we could talk about domain and range, but I'll briefly talk about this as well here. Domain is a set of all x values, and the range is a set of all y values. So when I look at my graph, what is the lowest x value that I see on my x-axis? Well, I'm going to look at everything from left to right. I'm going to go from negative infinity to positive infinity. Everything's acceptable from left to right. And I can use interval notation, or I could even use set builder notation. Everything less than or equal to x, less than or equal to infinity. All the notations we've been discussing before can be applied here. As for range, I'm looking at the y-axis. What is the lowest y value and what's the highest y value? The lowest will be down here at the bottom. And since it keeps going to the bottom, we're going to start at negative infinity all the way up to 5. That's the highest it goes. So my range would go from negative infinity to positive 5. And there's a bracket because it includes the point. It stops there. So let's try a few examples. Here I have two scenarios. I'm going to focus on the one on the left first. I'm going to start to describe the different places where the function is increasing. I can see here from left to right the graph is going up. Then it starts to go down. Then it remains the same. Then it starts to go up again. And then it stays the same. Right? It remains constant. So let's describe those locations. it's going to be increasing from the left, the negative infinity. There's an arrow, right? Meaning it's going to the left, all the way to negative 8. Negative infinity to negative 8. It's also increasing here. So there's two places where it's increasing. This side and this side. And the second location starts at negative 3, and it goes all the way to negative 2. From here to here, it's going to go up. We use the union symbol from negative 3 to negative 2. And again, I'm using parentheses because at these points, it's neither going up or down, right? It can't do both things. So I just use parentheses to describe the space between the two. When is the function decreasing? There's only one spot, from here to here. From negative 8 to negative 6. That's the space, or the set of x values, where it's going to go down. From negative 8 to negative 6. Now there's two places where it's constant, here and here. Constant just means that it's not increasing or decreasing. It stays the same. So the first location is from negative 6 to negative 3. And the second location is from negative 2 all the way to positive infinity. That's pretty much it. We can talk about the domain and range as well. The domain, if we're looking at the x values, we're going from left to right. The smallest x value will be here on the left. There's an arrow, which means it's going to go from negative infinity all the way to the right, which is positive infinity. And the range is vertically from lowest value to the highest value, right? The lowest it will be negative infinity. And the highest value on our graph will stop at 3. Notice how nothing goes beyond 3. Even though there's an arrow here that says it's going to go to positive infinity, all these values on the graph, no matter how far I go, are all at 3. That's the highest y value. And I put a bracket because all those points do exist on our set of y values. So why don't you give this a pause and give the second one a try. Give this one a try. How would you describe this behavior? Let's start with increasing. The graph is going up in two locations. Here and here. So let's look at the x values. It's going to go from, I can add more points here if I want to see the details, from negative 3 all the way to negative 1. Now here, I will put a bracket at both of these, because notice how at negative 3, it's only going up. It's not increasing and decreasing like we did over here, right? Negative 8, it was increasing and also decreasing. Here, this point exists only at one location and it's going up. So I'll put a bracket on both because it includes both locations. The other increasing location is from here to here, from 3 to 5. At 5, we have an endpoint, so we're going to put a bracket. And at 3, notice how at 3, it goes down and up. Since it's doing both, increasing and decreasing, I'll just put a parentheses. This just tells me everything between 3 and 5 is increasing, but not including the 3 part, because 3 is doing two things. Just between the two numbers. All right, let's look at decreasing. There's a spot here where the function is going down. And that's between 1 and 3. At 1, we can put a bracket because it's only doing one thing. And at 3, since it's doing two different things, we'll put a parentheses. Now, as for constant, When is the function staying the same? Here. From here to here. And I can use this value at -5. We can put a bracket, and then it goes all the way to -3, where there's an open hole, so parentheses. We're just describing the behavior, right? What is it doing on the graph? And then we won't worry about domain and range. We won't look at all the values that are here that existed. If you need more help with domain and range, I have another video in my other playlists that are just domain and range, and I have a ton of other examples. So if we can describe the graph or the intervals or the set builder notation where the function is going up, going down, or staying the same, we can pretty much describe the function and its behavior. I hope this has helped. Please let me know if you have any questions. And as always, we'll calculate.